Properties of gas and its general characteristics. Before you can even understand how a gas burns, you need to understand how it's made up. What is its characteristics, and how does it affect a furnace from burning efficiently? So, chemical composition of gas. All of our gases that are in HVAC that we use to supply heat is called a fuel gas. The majority of those fuel gases are a hydrocarbon, which means that they are made up of both hydrogen and carbon. The different numbers of hydrogen and carbon atoms actually makes up what the different types of gases are capable of doing and how much heat they are actually capable of producing. So, for example, here, methane. Okay, methane makes up a large portion of natural gas. It has one carbon atom linked to about 4 hydrogen atoms. Okay, so its chemical name for it is CH4. Ethane, on the other hand, is slightly heavier than methane. It has 2 carbon atoms and linked to 6 hydrogen atoms. And that scientific name, chemical name, is C2H6. Propane is even heavier than the other 2. That one has 3 carbon atoms and 8 hydrogen atoms. And that chemical name is C3H8. So as you can see so far in these last 3, the big difference between them is how many carbon atoms and how many hydrogen atoms are actually linked to each one of these gases. So one of the big things that we need to understand about this is that the more carbon and hydrogen atoms we have associated with these gases, the more heavier the burn these gases and the more heat they are going to be able to put off. And every single one of these gases require a certain amount of air that needs to be associated with them in order for them to burn completely. Like, look at butane here. Butane has 4 carbon atoms and 10 hydrogen atoms. Butane is a heavy gas. Okay, it's going to need more air. It's going to need a lot more to help it burn along, to help complete the combustion process. That chemical name for that guy is C4H10. So carbon and hydrogen, the number of carbon and hydrogen atoms in each one of those fuel gases affect the nature of the gas. The more atoms the compound has, the heavier it is to air. So the larger number of your hydrogen and carbon atoms in the fuel, the more heat that gas is going to be able to be released. Some additional characteristics for your fuel gas, such as how easy it can be controlled, and the flame depends on the number of carbon and hydrogen atoms. The more carbon and hydrogen atoms we have on a particular gas, the harder it may be to control. The more safeties we may need to have in that particular piece of equipment in order to shut it off in the event of some sort of unsafe situation. So common fuel gases that we deal with are not simply one kind of hydrogen carbon, but a mixture of many of the different gases. So fuel gases seen in HVAC alone may contain other gases such as carbon dioxide. It may contain a little bit of nitrogen. It may contain a little bit of free hydrogen. And none of these are 100% pure, which means there's always something else in there, these gases that go along with it, that will burn and cause incomplete combustion in some cases. So we need to take added measures and added measurements as we go through this to figure out whether or not the gas is actually burning off properly. Okay, natural gas is organic in nature. It comes from dead and dying plants from long ago. Okay, usually found in areas where oil is usually present as well. Okay, oil and natural gas, they kind of go together. Okay, oil we have in the ground, one of the byproducts of oil is natural gas. So chances are, as we dig down into the ground in the oil and natural gas industry, once they hit a pocket of natural gas, chances are, if they dig down a little bit deeper, they may actually find a pocket of oil there as well. Some natural gas from garbage and cow manure is now being used as well in the industry. Then we deal with liquefied petroleum gas, or LP gas. LP gas is propane or butane, or it could be a mixture of both of those together. Okay, LP gas can be transported and stored in tanks. Okay, propane, your gas grill outside. Propane is also used to heat houses. If you look around maybe your neighborhood or something like that, you may see a couple of tanks that might be painted white that are sitting on the side of the house. Those are propane tanks. Okay, LP gases are usually used in areas where gas lines are not readily available or haven't been installed yet, or for whatever reason maybe can't be put in, maybe because of the surrounding area. So they will put in LP gas to help heat a home. Okay, LP is stored under pressure. So much of the gas actually in the tanks is in a liquid form. So as the gas is drawn out of the tank, it has to first turn into a vapor or a gas, as the same way as other gases, in order for it to be burned. Okay, natural gas has little or no odor to it, and it has no color. Okay, so an odorant is usually added to that gas prior to distribution in aiding in leak detection and for safety. Okay, most odorants that are used is actually a sulfur, in which a lot of people, when they smell it, give it that gassy smell or the smell of rotten eggs. What you're smelling is the sulfur that was added to the gas to help find leak detection and for safety and all that stuff. Okay, specific gravity for gas is an important part of all of this. Specific gravity is the weight of a substance compared with the same volume of another substance. Okay, for example, fresh water is used as the reference substance for liquids and solids. Okay, if a specific gravity of a liquid is 2.0, it is twice the weight of the same amount of water. For gases, we use air as that reference for a substance. Okay, specific gravity of a gas is calculated by weighing 1 cubic foot of gas as compared to 1 cubic foot of air. Both air and gas must be at the same temperature and pressure when this comparison is actually made. So the amount of gas in a given volume will change and vary with pressure. One thing to always remember in HVAC, temperature and pressure will always coincide with each other. The warmer the temperature is, the higher the pressure. The lower the temperature, the lower the pressure. The pressure will vary with temperatures as gases expand and contract based off of that temperature change. So the specific gravity of air is 1, and that is used for reference material. Okay, the measured standard temperature for all of this is 69.8 degrees and at a pressure of 29.92 inches of mercury. Those two numbers are important to remember when you are dealing with gases, because that is pretty much the standard in which they measure all of this stuff. Okay, so natural gas has a specific gravity of 0.4 to 0.8, where air has a specific gravity of 1. So therefore, natural gas is lighter than air. So if natural gas was to leak out of our gas line, it will rise up into the atmosphere, okay, because it's lighter than air. Propane, on the other hand, and butane, they have a specific gravity of 1.5 and 2.0. These two are heavier than air, and these gases are released into the air. They will fall instead of rise. Okay, propane and butane can be dangerous. If we have a propane or butane leak from a natural gas, from a gas line, it will pool in low-lying areas, okay, and they will not mix readily with air. That can create an explosive environment if the concentration gets too high. Okay, butane and propane will drift into those low spots and pool, creating an explosion hazard if open flames are present, or heck, even if an electrical spark was to occur. So why do we need to know about specific gravity? It's important to know the specific gravity because it's important to know the effects of the flow of gas through gas orifices and the effects that the burner in a furnace is going to fire. Okay, a gas orifice in a burner is a small hole that's in a fitting, or called a spud, and it is used to limit the gas flow to the burners. Now, we know already what the chemical composition is of each one of the gases that we can encounter in HVAC. The more atoms we have, the heavier the gas is going to be. The heavier the gas is going to be, the more pressure we are going to need to push it through our gas lines. With that being said, we may need a bigger or smaller orifice in order to regulate the proper amount of gas to the burner so that we are not overfiring or we're not underfiring a burner. Okay, so heat energy produced from burning of fuel is commonly expressed in British thermal units, or BTU. Okay, 1 BTU is defined as the temperature. A BTU is defined as 1 BTU will raise the temperature of 1 pound of fresh water 1 degree. So burning an ordinary wood kitchen match produces about approximately 1 BTU of heat. Okay, and this is a nice comparison of what we're just talking about. 1 pound of water at about 70 degrees plus 1 BTU of heat will raise that 1 pound of water to 71 degrees of heat, or 71 degrees. Okay, so here's another example of heating values for gas. Say we need to heat 10 pounds of water to 100 degrees. That's going to require 1,000 BTUs of heat in order to do that. Okay, the heating value of gas is the amount of heat released when 1 cubic foot of gas is completely burned. In order for that to happen, we got to be able to burn all the atoms that are being released into the burner. Natural gas, primarily methane, which is all it really is, has a heating value of about 950 to about 1,150 BTUs. But for the sake of simplicity, we usually just use the BTU value of 1,000. We say that natural gas puts off about 1,000 BTUs. Propane, since it's heavier, is going to put out roughly about 2,500 BTUs per cubic foot. Butane, since it's slightly heavier, is going to put out roughly about 3,000 BTUs per cubic foot. Okay, remember, the chemical composition of your gases is what's going to determine how many BTUs of heat that gas is going to put out. Another unit of heat energy that we use in this industry for fuel especially is called the therm. A therm is 100,000 BTUs of heat energy. Say a therm of natural gas is 100 cubic feet of gas. So to figure that out, we take 100,000 and we divide it by the 1,000 cubic feet that natural gas is able to put off, and we come up with 100 cubic feet of gas. 40 cubic feet of propane contains a therm of energy, and we do the exact same thing. 100,000 BTUs divided by 2,500, because that's the amount of BTUs that 1 cubic foot of propane can put out, and we come up with 40 cubic feet of gas would be needed to produce 100,000. Input rates for how much gas that we're going to use per hour is a measurement of the appliance. If you look at a nameplate on a gas stove, or if you read the manufacturer's literature on like your propane grill outside, it has an input rate for each one of our burners. Input rates will be measured in cubic feet per hour. Okay? Input rates, however, they can be converted to and from BTU per hour by using these following formulas here. Okay, so what we can do if we needed to figure out the input rate of a specific piece of equipment, we need to know the heating value of that gas per cubic foot, and we need to times that by the gas flow rate in cubic feet per hour. Okay, if we needed to figure out what the gas flow rate is in cubic feet per hour, we need to take the input rate in BTUs per hour and divide that by the heating value of the gas in BTUs per cubic foot. So here's an example. We have a natural gas water heater, and it needs 35,000 BTUs per hour to work. We need to figure out what the gas flow rate is. We're going to take 35,000 and divide it by 1,000. Because remember, 1,000 is its BTUs per cubic foot of gas burned. If we take 35 and divide it by 1,000, we come up with cubic feet per hour of 35. So that furnace or that water heater would need approximately 35 cubic feet of gas per hour in order for it to deliver 35,000 BTUs per hour. Input rates are important for gas pipe sizing for a particular appliance and furnaces. All of your gas lines on a street, on a building, all needs to be calculated. We need to be able to size the gas line to be big enough to be able to deliver the correct amount of gas to all of the appliances on the road or in the building if they were to turn on all at the exact same time. But the bottom line is the appliance must have enough gas to run efficiently. If we do not have the proper amount of gas to an appliance, we're not going to be able to deliver the correct amount of heat for the space or for that water heater or for that gas furnace to effectively heat what it is that we are trying to heat.